Delighted to have, I guess, three very significant companies, each in their own right. Intel, the world's largest semiconductor manufacturer.
Hi, Bergen with Intel. I manage our global water stewardship program.
Facebook, the world's largest social media company.
Hi, I'm Lauren Sweezy, and I lead sustainability for Facebook in the Bay Area, which includes our headquarters.
And Nike, the largest sportswear apparel company.
My name is John Majeski. I'm the director of water programs at Nike and the Sustainable Manufacturing and Sourcing Group, focusing on supply chain water efficiency.
So from very diverse areas, and I think what unites them here today is their relationship with water and how water affects their business. And more importantly, the leadership role that they're taking in looking at how to manage water within each of your businesses and show leadership and innovation. And that's why the title of the panel is the Lighthouse panel. It's designed to signify the fact that a lighthouse shows a way forward. And I think the stories that we'll hear today each capture an element of trying something new, something different, and something that if we embrace it and scale it, it will move the needle. So without further ado, I'd maybe like to turn over to Lauren Sweezy.
Hi, yes, I'm Lauren Sweezy, and I lead sustainability for the facilities side in the Bay Area, San Francisco Bay Area. And that's where our headquarters are in Menlo Park, California. And we have buildings around the Bay in San Francisco and the South Bay.
And Lauren, I think your campuses are really famous the world over. People have iconic images in their heads of slides and all sorts of things. And I had the opportunity to visit the campus in January, which seems like an eon ago now. I was very fortunate and lucky to get there before the lockdown. And, you know, funnily enough, one of the things that did strike me was the availability of food, which it turns out had a curious role to play in your water reuse story subsequently. So maybe you can begin by telling us, like, contextually, why the project was needed or where it stemmed from, where the origins of all this were.
The first question we got from the media was, are you using any recycled water? And the reason was because we were in the middle of a multi-year drought, and drought was on everybody's mind, yet they see this big garden on the roof. So of course unfortunately, we were not able to even put purple pipe in that building because it wasn't allowed by the local agencies at that time. And so I immediately thought, we need to start looking into reclaimed water. And that would be an on-site system. I had been introduced to a system called Aquacell, which is out of Australia, in 2014. And I thought this could be a really great system for us because it's very compact. It fits. It doesn't take up a lot of room in a building except for the tanks, which we were able to put underground. But it's a great, reliable system. And so I introduced it to the team, and we started going down the road of figuring out whether this was going to work for us. We did take a slight turn in that process. The team wanted to look at a wetland system, where a drain and fill wetland system. And those systems require a lot of land because you have the wetland outside. And we went down that road for almost a year, and then we came back to the Aquacell system because it's such a compact system.
It's really interesting to look at the alternatives you have to explore, and each one has its merit. It's all just a question of what works best in that context, for you.
Exactly. That was the drain and fill wetland is a great system in the right situation. It just wasn't going to work in our situation. And I think also we felt like that the Aquacell system was dependable. We understood how it operated, and we could, install a reverse osmosis system, which would help us on the dissolved solids and reduce the amount of salt content and such, so that we could water the green roofs and not harm the plants.
It's actually one of the things that crops up quite a bit, isn't it? When you look at reuses, surprisingly, it's the salinity, and it's not that it's saline per se, but it's just about high enough that for a redwood tree, it might pose a challenge.
Exactly. And we've heard stories, about local water affecting redwood trees around the county, and we didn't want to take a risk. And so we adopted a system that, really it cleans up the dissolved solids. It's very safe. It uses UV, but then we added the reverse osmosis so that we could be guaranteed that it wouldn't harm the plants.
I guess at that point you felt, great, we found something that works, we evaluated the options, but I think it turns out that was maybe just the beginning of the journey, and there were a few other twists and turns along the way.
It was a long journey, let me tell you. Yes, there were a lot of twists and turns, because it turns out no one had ever put one of these systems in buildings before, or commercial buildings particularly. Our region, the Division of Drinking Water and the Water Quality Board had never permitted a system in a commercial building. Our local building agency didn't know anything about this. It was not in the code books. So they, said early on that they were not going to approve it because it wasn't in the code books. The only area where we got a lot of support early on was the health department, surprisingly. They really saw that this was feasible and that we should move ahead. Later on, we had a cheerleader in the Water Quality Board who wanted to see these types of systems implemented, because our regional water is in short supply, as you may know. In California, we have constant droughts, and we're on mountain water from the Hetch Hetchy system in the Sierra. There's a defined amount of water available, and people can't just add more water to the system. And so these will help supplement water that is used, good, very high quality potable water that otherwise you'd be flushing down the facilities. So this will save up to 17 million gallons annually between two buildings.
Yeah, no, and I think it's the largest district scale water reuse system in California, and it's certainly one of the top in the US.
Yes, and as I say, not very many people had tried these in commercial buildings. There might have been a gray water system here and there, but black water had not been achieved.
There was one nuance to it that I find is very interesting. It's that when you went to regulate it, the regulators were struggling with it. Almost your challenge was to almost educate them and bring them along with you on the journey. And I think the fact that there was some food available to your workers created some, I guess, a gray area in their minds.
Exactly. So when we first showed them the plans for our building, which included the purple pipe and then the regular water distribution lines, they had a difficult time really understanding where everything went, because it's two-dimensional. And their biggest concern, especially at the Division of Drinking Water, are cross connections. And you can't have cross connection between recycled water and potable water. And so we were going around and around. They told us that according to our Title 22 in California, you couldn't put purple pipe where there's food in a building, and we have cafes in our building. So we were interpreting it a little bit differently. The cross connection and the purple pipe in a food, we're not producing food. We are just cooking food in a facility, but we're not a manufacturing site. But where the education came in, which was really fascinating to me, was we ended up taking the whole team from the Division of Drinking Water and the Water Quality Board to our engineering offices, where they had the ability to show in 3D modeling the infrastructure, and suddenly they understood it all. It turned on the light bulb, so to speak. They could see that it was designed so there was no cross connection issues. Of course, it had to be tested later to make sure, but that was when that sort of turned the tide, so to speak. actually they started getting on board, realizing that we were able to do everything accurately, and it went on from there.
Yeah, I guess seeing is believing in 3D, at least to begin with, and that provided some comfort. I guess having gone through it, I'm always curious to know, if you could turn back the clock now to 2 or 3 years, would you do anything differently than what you did?
Well, there are a lot of lessons learned. I think we now understand the pluses and minuses of the different systems. We understand, the education it took, and I don't think we could have approached it any differently. I think we had to it was going to be a slow process. But I think now that everybody in the different agencies are educated, if we were to do another one, it would be a lot simpler.
You were a pioneer essentially in what you were doing. It sounds like that's not always the easiest place to be.
It's difficult to be first, for sure.
Well, thanks, Lauren. Look, that's an inspiring story. I think it's an interesting segue to look at the textile sector, John, which you're involved with. And I guess with the world's largest sportswear apparel company, you're very visible in the sector, and the textile sector itself is very visible in the world of environmental sustainability. But perhaps we can begin with, you're based in Portland, Oregon, close to HQ. Did you ever think, years ago before you joined Nike, that you would be doing this job within Nike?
No, Paul. Actually, I moved to Portland in 1993, and I used to drive by the Nike World headquarters all the time. And on my way to my water engineering job in the high tech industry, and I'd always drive by, and I'd be like, "There's Nike. Oh, there's nothing in there for me. There's what would a water engineer do at Nike? What would a water engineer do at Nike?" I'd drive by it. I wouldn't think anything of it. And then in 2014, they had an opening. They realized they needed to elevate the focus on water and water sustainability. And as a result, they opened it up, and I applied and moved from high tech to textiles. It's been an interesting journey, I will say. I've been doing a lot of learning. It was a pretty steep learning curve when I first joined in 2014 on how the industry worked, where the water was using, and primarily the water is used in dyeing and finishing. For your favorite color shirt, for your favorite color shoes, that's all water intensive process in the dyeing and finishing. And as a result of that, there's a wastewater that has to be dealt with, and there's a lot of fresh water that's used as well. So what we find is there's a lot of opportunity for water conservation. In 2014, right after I started, we set our 2020 target of 20% water reduction by 2020. At the end of our fiscal 19, we were down by 25% from our 16 baseline. So we already hit it. We hit it 18 months early, and we had that opportunity to do so. What we find in the field, it's a lot about awareness. If I had to pick three things, it's awareness, commitment, and capability. When I first joined, we created a document called the Nike Water Minimum Program, which sets basic expectations of our suppliers. They have to create a water balance. A lot of them don't have water balances. They have to look at their water risk to see whether they're in high risk regions, and then they got to look at their water conservation. How can they find water? How can they find opportunities for water conservation? And how can they treat their wastewater better? And just for everyone, if they're not aware, Nike doesn't own any of this manufacturing. This is all subcontract manufacturing, where we then have to influence the suppliers to adopt best practices. So now, once with sorry, Paul.
No, and one of your suppliers globally would be in Mexico. Well, you operate across a global supply chain from Asia, Latin America, all over the world, essentially. And I think you've had some success with some of these people in different locations.
Yeah, for example, in Mexico at a company called Vertical Knits, they make cotton. They do cotton T-shirts and cotton apparel, and they back when we first rolled out the minimum program. At first, they looked at it. They did the water balance. They found a hole in their water tank. They realized they were losing money because they were losing water, and then 2 years later, they were able to reduce their fresh water use by 80%. They went in, they optimized their manufacturing process. They took the human element out of manufacturing. They automated manufacturing. They put in a water recycle system, a new wastewater treatment plant with an MBR and RO, and they were able to bring their fresh water down by 80%. So they were a leader in this. I mean, in 2 years, they were able to drop their freshwater use by that. And we tell the folks in the industry that it's possible to reduce freshwater use by 90% using commercially available equipment with capable people. And we were pushing the capability building because that's really, in the end, the root cause of a lot of the issues we're seeing out there, because a lot of folks they're going to be aware of the work that they do. They're committed to fixing the problems that they identify, but they may not necessarily have the right background or the right skill set or to achieve that. And we see a lot of areas in the industry where there's an opportunity to instill generally accepted best practices that we see within the water industry that have yet to jump over into the textile industry. So we're on this big capability push right now. And Vertical is a good example. They have qualified people, they are aware, they're committed, they're capable, and they had a win.
How did you win the hearts and minds and persuade them that this was a good thing to do? Is it a carrot and a stick approach, or how does it work?
Well, it wasn't necessarily a stereotype. They just saw that there's a benefit to it. They saw that there was money to be saved. Right. I mean, in parallel to their water conservation, they also were able to reduce their energy conservation by 50%. So today they've doubled their production and they're still using the same amount of electricity as they were 5 years ago. I mean, and that's just money in the bank right there. I mean, we don't really use a carrot and stick. We encourage our suppliers to move down a path and start looking at things. And then they become aware and they have an aha moment and they realize how much money that is not being saved because of the way they're operating their water and wastewater and how they're using their fresh water.
Yeah, it's fascinating. I think one of the things that struck me when you shared that story with me first time around was the fact that by making the manufacturing more efficient, they had less waste material. By processing less material, they used less water. So it had a curious knock-on effect right through the manufacturing process.
Oh, for sure. And they're able to, Paul, they're able to not only save less chemical, less water, less energy, less manufacturing space tied up in doing rework, right? So there's this other opportunity there as well. So it just multiplies over time by bringing the manufacturing side of it. But really what we've been pushing at Nike over the last 5 years to hit our target early is water recycle. And we're doing this in a closed loop way. So Nike is a member of the Zero Discharge of Hazardous Chemicals Foundation, ZDHC Foundation. We created a wastewater guideline, which defines what the quality of wastewater should be at just being discharged from a facility.
The fact that you're moving, not because you're regulation driven, but it's a standard that you're developing that you wish to observe across any jurisdiction. So it really, it runs transboundary, trans-country.
It is, and actually the other thing too about our supply chain is we share them with other brands. So we share our suppliers with our peer and competitor brands. And they're also members of the ZDHC. So they've signed on to the ZDHC, they made the commitment, they expect their suppliers to meet that. So when we talk about the water savings we've been into a lot of facilities. I have a team of folks around the world, engineers and consultants, Nike employees, who go out. We have a Nike water team, by the way, not just one or two people. We're very fortunate to have that team. And it just goes to show how committed Nike is to water sustainability because we have a team of people. I think we're the only brand or one of the few brands that has a team of engineers and consultants that go in and work with our suppliers solely on water projects.
And I think that raises the point that so often people who think about the textile sector, they think it's a very polluting industry. Can you tell us a little about why textile wastewater in particular is difficult to treat? What is it that makes it challenging? When
we design a shirt, a color, I mean, there's a style there. There's a expectation of quality, and it's in color fastness. Color fastness is something you want. If you have a dark, deep navy shirt, you want it to stay deep navy. You don't want it to fade over time. And as a result, the dyes that are used to make that are robust. They're meant to not degrade in an oxygenated environment with moisture and biology, otherwise known as a sweaty football jersey at the end of a game. You don't want that to fade. You don't want that to run. You don't want the colors to fall out, because that goes against the whole idea of quality and performance. You don't want that. So these dyes now are getting into the wastewater at these manufacturing facilities, and what we're finding is that a lot of the manufacturing facilities are using aeration basins, which is biology, water, and oxygen, to treat their wastewater. But the dye is not designed to degrade in that environment. Those that have the anaerobic basin before the aeration basin, they're doing a fantastic job. Those that don't, not so much. That's the challenge.
So with that, I guess we'll segue to our third panelist today, Fawn Bergen, with Intel. And Fawn, I guess you operate at I would say probably in the cleaner side here. You know, if we're being honest here, high tech uses ultra pure water, and a lot of it, and it's fundamental to the chip manufacturing process. And we'll talk about how you set goals and where you get to them. But perhaps just to begin with, can you tell us a little bit about your own background and what your journey was that brought you to the role that you currently have at Intel?
It's sort of interesting to me, and I would have never imagined I would be working in water. My degree is environmental engineering, but most of my career has been focused around air quality, compliance, EHS type roles. And when I joined Intel about 5.5 years ago, I was hired for a corporate air position. And about a year later, they broke off the sustainability team from environmental health and safety. And I joined the group and thought I was going to be working on carbon footprint and waste, and ended up getting to work in water. And it was right at a time where we were thinking about what is next for us on a water leadership journey. So it ended up being in the right time and place, really, because I got to create this whole new program, develop our water strategy, and then put that in implementation. And so I got to not only kind of build the program the way I want, but also I get the satisfaction of seeing these projects completed and the impact they have to the local communities or watershed.
And I think you just completed your 2020 goals, and you're now setting your 2030 ones. A little bit like John's story, I think you hit your 2020 targets.
Yes, we just released our corporate responsibility report about a week and a half ago, and we did close out our 2020 goals. We achieved all of the goals. We had two were related to water. One of those was our commitment that we made in 2017 to restore all of the water that we use around the globe. That one was set on a different time scale, so it was extended as part of our 2030 goals. But we also had a water use efficiency goal that we did achieve. In fact, we surpassed it. Our target was to reduce 10% on a production unit basis, so it was an efficiency normalized goal. And the goal was to get 10% below our baseline year of 2010, and we achieved about 38%. And this has been through a period of significant growth and increased production for the company. It was definitely a challenge to get there.
What strikes me about the numbers we talk about here, they're in double-digit percentages. And if we look at the scale of the water problem, it's those types of dents that you can make are significant. They go an awfully long way to taking what we know is a water crisis that's barreling down upon us to being on the other side of it. And I think you've just recently announced the 2030 goals.
Yes, I'm really excited about those. This time around, we really wanted to make sure the goals were integrated across the company, meaning we're not just thinking about water in our factories, we're looking at it, our entire value chain. We're different than, say, a food or beverage company where we require large volumes, as you said, of ultra pure water, which is the cleanest water on the planet, the closest you can get to pure H2O. We use that in manufacturing. So our new goal was taking our focus is to reduce the use of fresh water. And then larger scale, we've been in the process of expanding and constructing 3 very large water reclaim facilities in Israel, and then in Oregon and Arizona, they're under construction. So those are huge long-term strategic investments. And so that's part of the net positive water use, is being as efficient as we can, and we still have opportunities. We're not 100% there, but looking at kind of that ideal state, or we call the total available conservation. So if all the barriers removed, what is the max that we could do, and then develop a roadmap to get there. But on top of that, the nature of how we use water, we lose about 20% of all the water that we bring in. So water is not tied up in our product. The 80% is treated and returned back to our communities. And then we have some sites, a lot of sites that reuse the water on site as well. And so we still have to supplement about 20% of the water that we bring in. It's lost mostly in evaporation in our cooling towers. And we also use them in site systems like scrubbers. And so in addition to optimizing that, the big commitment, the new commitment we made in 2017 was to close that gap. So that 20% that we consider is consumed or lost, we are investing in our watersheds projects with environmental organizations like the Nature Conservancy, National Forest Foundation, to fund a portfolio of projects that they solve one or more local water challenge. So it's very, very specific to the location.
I was fascinated to hear about one of the projects where, not one you would think about perhaps if you think of Intel, data centers, semiconductor manufacturing, but it was in India, in Bangalore, involving lake restoration. I'd love if you could just share a little bit about that project and what the goal was.
Yes, it's a wonderful project. So excited about it. We're partnering with an international organization called Clean International, and they're working with a local NGO called Say Trees. And the project is, if you're familiar with the Bangalore area, the area was famous for all of their lakes, just beautiful, pristine lakes, thousands of them. And many of them have dried up or been degraded with pollution. And this project it's a really amazing project in that it's somewhat simple. It's rebuilding the natural infrastructure and resilience of the lake that was there at one point, not only to have something beautiful for the community to enjoy, but also to help promote groundwater recharge. That's one of the aims of the project. So what they're doing is they're taking this lake, it's called Lake Nonjapora. Hopefully I'm saying that correctly. It's in Bangalore. They're excavating all of the sediment, and they're taking the sediment that they recover from the lake bed and building a walking path around the lake and planting, I think it's in the thousands of trees. So there'll be shade there as well to help protect the water, as well as just a beautiful place for the community to enjoy. Clean and Say Trees, they've done a couple of these in Bangalore already with great success. We broke ground in January, and the project is supposed to be finished in a couple of weeks. So we're really excited, and just think it's going to be a wonderful thing for the community and something that is very much needed in Bangalore.
Yeah, I guess viewing it all in the round for the three of you, coming from both semiconductors, social media, and textiles, the challenges are different, but there are probably some unifying things as well. I'd just love to know if you had to think about, as you set goals, what would you say are some of the hardest parts in achieving those goals? What is it that would keep you awake at night, if anything?
I'd say in the tech industry, and Intel is probably more unique in the sense that we are a manufacturing company. A lot of our tech peers, their big water footprint is their data center, which is, a challenge in itself. But ours is related to technology as well. And what I mean by that is, with each new technology that comes out, we're creating something the world has not seen yet, with each new technology that comes out every around every 2 years. And so having the opportunity, but also the challenge of trying to predict where that's going to be in 10 years to set a goal. I'd say Intel, we're probably more on the side of wanting to have a plan to get there rather than, making this large aspirational commitment to say, we'll figure it out as we go. We want to know that we have a path to get there before we make that commitment, even if it is a lot of unknowns in there. That's been extremely challenging for us in not just the growth. Thankfully, our industry is growing, and a lot of our factories right now are expanding. So we have that upward curve from growth and more production, but also with each new technology, the complexity of each chip drives the need for more energy, more water, in everything that we do. So we have this very steep curve that we're trying to get ahead of and get it going in the opposite direction.
Very good. Thanks, Fawn. It's really interesting that as you move forward with the technology itself, you need higher purity water. You may need more water because the way, as we've seen during the pandemic, the reliance on this technology, all of us are speaking remotely, and it's fantastic that we can do so. This all needs cloud computing, it all needs processing, it all needs data storage, and that's going to fuel a demand for water. So I guess there's a license to operate piece here. And at the same time, you have to deal with the fact that water is going to be less available. I think actually Intel, you do tend to locate these in some dry regions, parts of the world.
Yes, we do. And, I find it interesting myself. Most of our properties were not built by Intel. We purchased an existing, brownfield site. And we operate in some pretty water sensitive regions around the world. And I think that's why it's, even that much more important. We view it not just as kind of a business continuity. If we don't have access to very high quality water, we can't make our chips. It's just pretty simple. It's absolutely critical to do that. And I, like John, before I worked in the tech industry, I had no idea that water was so critical. I don't think most people, when you're using your laptop or whatever device, but it's also, if you've ever seen one of our campuses, it's huge. I think it's almost like a university campus. And so it's extremely important that we also build a good relationship with our community. We want them to think of us as a good neighbor. So it's all of those reasons that we feel we should be investing in these things, and we have an opportunity to do more, and therefore we should.
Yeah, I think, Lauren, I'd be interested to hear from you. Your campuses also are massive and are global, and I'm wondering if there are things that create some sense of concern for Facebook, or specifically other than the buildings or the data center side. What might they be?
Well, I think it's the same story here. We use water throughout our company. As you can imagine, we have a lot of data centers, and a lot of those data centers are now located in areas of where water is in short supply. And so, like Intel, we are involved in a lot of restoration projects, and specifically to support the local communities, to restore habitat around water. But what I think about is the supply of water. California and other parts of the United States are constantly going through droughts. And, we know California, with climate change, they're just going to get worse. And so we are constantly thinking about how are we going to solve the water issues. So when we design our buildings to begin with, we design them so that we use about 40% less water than the typical building. And that's just through efficient fixtures, et cetera. But beyond that, a lot of our buildings are also lease spaces. And so we don't have the opportunity to put in, a water system purple pipe or whatever. We're taking over an existing core and shell. Oftentimes it might be a new building, but we take over what we're given. Globally, again, water insecurity is global, and so we're constantly working to find different ways to make our data centers more efficient.
And that's an interesting common theme, actually, which unites the idea of habitats. And of course, operating with existing infrastructure is challenging. I visited the Starbucks HQ in Seattle earlier this year, and it's LEED Gold certified. And that was one of their biggest challenges. It was to take quite an old building and try and get it up to spec is challenging. It's easier when you're starting with a blank sheet of paper. That's for sure.
That's true. We discovered that in some of the older buildings that we were using in New York City and taking over in New York City and London and such, that those older buildings don't necessarily have the same infrastructure as other buildings, and you might not be able to utilize some of the most efficient fixtures because of the issues with distribution and such. So there are many challenges when you take over older buildings.
It's interesting, Fawn, when we discussed about the water scarce locations of some of the Intel fabs, I was reminded of the fact that there's a fab in Dublin and there's a Facebook HQ in Dublin as well. And it's actually water scarce. It actually suffers from water stress. Like if you look at the WRI index, aqueduct, it's counterintuitive for a country which receives 1 meter, 1.2 meters of rain a year. But again, it just highlights the fact no one's immune to this. It really doesn't matter where you are; you can be exposed to these issues. John, from your perspective, would you share any of the same issues that were raised by Fawn and Lauren, or are there different things that you think that are the biggest challenges that Nike faces?
I was thinking back to when I first started, and in the last couple of years, I would say, in the last couple of years, it's been a pull. Now I get questions. Hey, we're going to put in a wastewater treatment plant, and we're going to do water recycle. Can we ask you for advice? Can we help you? And then as more and more facilities as more and more companies and textile companies are building new facilities, they're automatically including water recycle and more improved wastewater treatment. We're starting to see it as being a pull, and then we still offer our services to review those designs, and we take a look at them and we feedback on those designs. Now they're coming to us not after they've bought the design, but before they've bought the design, which is even an improvement too, because now you can make changes without change orders. So it's becoming more. It's becoming somewhat easier. I don't want to jinx it, but it's opportunity. I wouldn't say keep us awake at night, but there's opportunity out there.
I think again that comes back to this idea of why we call this a Lighthouse panel. It's that we don't have to relearn all of this, and in fact, there probably are shared learnings. That what works over here could work over there, and that's something we're going to continue to explore throughout the summer and into the fall as we bring together different industry sectors, oftentimes for cross-pollination, in adjacent sectors where you're doing different things, but water is a pretty common thing and it's not something we compete on. In fact, in a given catchment, everyone needs there to be water for many reasons, but also because the people that consume these products, they need water to live healthy, fulfilling lives as well. And we need to allow those communities the opportunity to do that. So there are multiple drivers, I guess, not least of all the fact that there's an increasing expectation that you should do well by doing good at a corporate level. And look, it's great to see those stories. So thanks for sharing. I know it's not always easy, and there's more work to be done, but that was really engaging. I think our next panelist, Mark Nelson, a Bispherian, will tell us what it was like to live in a very, very small environment with a very, very finite amount of air, oxygen, water, and waste. And I'd be interested to hear his lessons learned and his reflections. So with that, I'd like to maybe thank you all very much and look forward to seeing you soon again.
Thank you.
No, thank you.
Thank you.
Thanks, guys.